Hi everyone, welcome to another episode of the Lisp Study Group. I'm your host, Ron Vadum with Atlanta Functional Programming. You might be wondering why I'm showing you some C++ code today, and that is because today we are going to be talking about the CFFI and some various experiments with the CFFI. As many of you know, the CFFI is the foreign function interface library that was standardized in the Common Lisp community for the past, I think, 20 plus years now. The notion of foreign function interface is not new to Common Lisp. It's just that there were various foreign function interface libraries out there that ended up getting consolidated in the early part of the 21st century, particularly around the second renaissance of Common Lisp, from my understanding. My first experience with the CFFI was way back when I started looking at Common Lisp to begin with, because I was interested in seeing how the libraries, particularly related to OpenGL at the time, could hook up so that I could interactively learn how to write graphics. There are many libraries like that already available today, so I'm not going to concentrate on doing those per se today. I thought I would give kind of a brief but very quick overview of the a way you can interface with Common Lisp with C. And I was looking at experiments of trying to see if this C interface could be used as a basis for hooking Common Lisp in with other languages that provide the ability to write C exportable symbols, essentially. So you could think of, say, languages like Rust, or maybe even, I believe, Ceylon and some of the other compiled languages like Zig also provide C interoperable shared objects that, assuming that the interface is well defined, which it should be because it is standardized C, you should be able to just load those shared objects into your Lisp code and be able to just use them directly. I'm not going to give a detailed overview of CFFI. Today's episode is primarily some various bits of experiments just to give you guys kind of a flavor of it. There are many detailed overviews already available online. Honestly, I don't think I can add more to the conversation related to them because the user manuals is fairly well documented for most use cases, plus some of the various YouTubers on YouTube over the years have given very, very nice overviews, best of which I've seen has been Bagger's 2-hour lots of Lisp overview of the CFFI, which I posted inside the YouTube description for today's episode. Feel free to reach out to him and his work. I can't really praise it enough, just because I periodically go back to it to see if there's some stuff that I've missed in terms of explaining a particular concept and so forth. So, as usual, this is going to be a normal discussion, open discussion. Feel free to post in the comments on the chat inside YouTube Live, and if there are any particular questions you guys are interested in discussing outside of this, feel free to ask, and I will accordingly answer them as I see them. As I was saying before, the CFFI, or C Form Function Interface, is a library that has honestly become the de facto standard way of writing form function interfaces inside Common Lisp. Prior to it, there were a couple of other foreign function interface alternatives, some of which were commercial based and some of which were open source. The most open sourced one that I remember was UFFI, which was the Universal Foreign Function Interface, but I believe the majority of open source projects and projects that actually use the UFFI switched over to CFFI. They were very similar in API definitions, and so they kind of, my understanding is they were able to consolidate the two into the single standard which I can show you today. The CFFI provides the various constructs for you to be able to actually load and interact with C libraries, C functions, and structures as well as enumerations in a way that is amenable to both Common Lisp and C. It provides the ability for you to define a C like interaction inside Common Lisp, so you could go ahead and actually be able to communicate with C in the way C expects, and when C returns something, you'll be able to use the CFFI to convert it into a object whose lifetime and semantics are very similar to what you would kind of expect when dealing with Lisp objects. Now, of course, because you're reaching out to an external programming language like C, one of the things that you need to be careful of is that the CFFI does not manage your memory. You are responsible with actually taking those foreign types and or objects that you bring into your Lisp image and appropriately free them. There are some concepts and stuff in there that I could bring up very briefly based on my experiments, but I don't want to go too far ahead. I'm just going to give kind of some brief interactions that I've been kind of playing around with just as part of this work of seeing if I could reach out to other external languages not specific to C. One thing to keep in mind when talking about C and even its system level programming languages is it's not just memory management but also resource management. Now, the same rules that you would normally apply when you're talking about resources going across boundaries apply here too as well. It would be ideal if you can keep track of, say, the resources that you are managing on the Lisp side as well as managing on the C side, so that you make the appropriate resource management strategies when you're passing across the wire. But again, that's a fairly advanced topic, that I will try to cover in a later episode when we get into some more complicated examples of these experiments. But I thought I'd mention it here because I know that would probably be an immediate question when folks are playing around with either taking their C library and hooking it up into their Common Lisp REPL, and or even potentially vice versa, which is possible with some Lisp distributions. So I want to also mention this one thing too as well, with relation to the CFFI and just dealing with foreign functions, interfaces in general, and even interacting with external programming languages. It is possible for some distributions, mostly commercial, and I've recently seen this in SBCL, for you to call in the other direction. So call Lisp functions from within your external language, right? So you can create kind of like a shared object. Well, not kind of. You will create a shared object that can be loaded into your C or C++ or Rust, if have you, program, and be able to use your Common Lisp library as if it was a normal function. Now, I've seen examples of this most recently with a open source project that I'm just going to briefly mention here, but I'm going to hold off on discussing it before we go and actually talk about the CFFI and kind of work our way up to it, called SBCL Librarian. This is coming out of the folks from the Quillang project. I encourage you guys to check that out. It will require some additional setup, primarily because normally when you get SBCL, you do not get the shared object version of SBCL. You only get the executable version of SBCL. I was in the process prior to today's episode trying to get that example working for you all so we can have a full featured call C from Lisp and Lisp from C kind of interaction. Unfortunately, on my box, I've been getting. I had some trouble getting a shared library with SBCL source that worked with some of the examples I saw from the SBCL librarian project. But once I have something more definitive, I will show you guys that for the time being. But in the meantime, I will post the SBCL librarian project GitHub on the YouTube description too as well for folks who are interested in seeing it too. So when you start up your REPL, CFFI is technically already available for you. You could probably, and the reason it's technically available for you is because each each Lisp distribution has its own form function interface that hooks into this higher level library. CFFI is kind of just universal version of it. But it doesn't actually, the actual ASD for the core universal interface does not actually load up by default. So we have to actually go ahead and load this guy up into our Lisp, and you can see it's going to load a bunch of stuff in here. One of the nice things about it is you could immediately start using this ahead with some of the simple C functions that are available to you as part of just SBCL loading up. Now, as many of you know, SBCL, even though it is a REPL for Common Lisp, it is written in C, and as such, it loads up the standard C library.
Rom?
Yes. As many of you know, my apologies. It looks like my Jitsi was on mute, but I hope folks on the stream are actually seeing this. What I was saying, up until now, C, the C library is actually loaded into the SBCL process because SBCL is technically, even though it is obviously a Common Lisp compiler and Common Lisp system, it's also a Unix process, and it's running on Unix, and it's actually written and its core is written in C too as well. So it loads up the actual standard C library. So even now, you can use the CFFI to actually go in and define simple wrappers around the existing C functions that are available to you. So for example, we could write, say, def C function, let's say, let's try ABS, which is going to take an integer and return an integer. Okay, and the way you do this is if you see this, you put name and options. Okay, so we say we're going to call this CABS. The return type is going to be a CFFI int. An int. It'll just go. It has to be like that. It uses a keyword argument. My apologies. And it takes in arguments, and these arguments have to be typed to as well. So let's say that we do if I remember correctly, this is the correct way of doing this. And if we compile this, 1 second. Doing macro expansions is nil. Int. I was trying this earlier. Do I have that example? Yes, I do. I messed up the correction. It's this way. This is the order. I have to create, let's say we do ABS, CABS, So that's the name of the C function, and then the actual function that we're going to call. And then we use int as our and we could just go ahead and get rid of this guy. And you can see this guy's already available for us, but we'll go ahead and complete this for our sake. Okay. So now, when we do a macro expansion of this, we can see what actually happens. Behind the scenes, what it's converting is it takes the function type that we provided. Okay, seal is in our case it's ABBS. We have also sealing already defined too as well. And it calls out to something called foreign function call from the CFFI sys function library. And this foreign function call actually reaches out and uses the appropriate name mangling, which is defined by the convention. As you can see there, that cdecl is a keyword that specifies the kind of mangling scheme, and it's a C declaration that you're ending up leveraging. And then it goes ahead and says if I remember correctly, this default library is just, I think, hooking into the actual library the standard library, if I'm not mistaken. Yeah, it's the standard library. The one thing that you may see, for folks who aren't used to looking at these kinds of macros that use gensim, the reason why the definition was gensimmed, the variable was gensimmed is because the actual variable name, the symbol name that we provided, A, was actually took in as part of the defun, but we can't use technically the same one inside the actual call because of what I was talking about earlier. There's going to be a symbol that needs to somehow match the semantics of the external language, and in this case it's going to be C. When we do this, we now have the ability to just now directly call CBABS, and you could see that we can actually go ahead and call our functions even, and you can see that the functions will appropriately get converted and call out to the actual C library itself. And in the case of this, you could see that with functions that are typed differently, we do not actually do, on the Lisp side, a implicit cast. So in C, you would end up expecting cseal to be able to take the 3, implicitly convert it to a double, and be able to return it. As far as I can tell from my experiments with CFFI, that does not happen, which is kind of nice because now you're forcing the ability to actually do what it's supposed to do. This is obviously stuff that you could probably see in other cases too as well. But I thought it would be useful to actually go in and talk about also loading up libraries fairly quickly too as well. But first, I will pause and see if there are any questions on this basic brief overview. Okay. All right. So just bear with me just for 1 second here, and we can get started on the next topic. So just pull up one more thing here. Oh, right. So one thing that I noticed in a lot of stuff that when talking about CFFI that I think is important to note is also what I was saying earlier, which is just a very quick thing, very quick note on managing memory. As I mentioned before, when you're talking about calling C from Lisp, or even the other way around it, or at some point when we start talking about it, you're going to have to deal with actually passing memory around from in many cases, one processor thread to another processing thread. So how do we actually go and handle that? Now, with CFFI, from my understanding, you have a couple of things that you have at your disposal, all right? Mainly the two ones that you want to keep track of is for allocating memory is foreign alloc and foreign free, all right? These are obviously your malloc and free, or new and delete if you're coming from C++. These are your hammers, if you will. Obviously, because this is C and malloc and free did not delete everything. If you're using like arrays, for example, just contiguous blocks of memory, you can use CFFI for an array free to handle every element inside of a particular array, so you don't have to write that loop code to actually go in and delete the actual array, which I thought was pretty cool. I'm going to give a quick example of this just because I want to explore the object that is actually being created, just for a brief understanding of what it's doing. So let's go ahead and create, and obviously I wouldn't suggest you to do this all the time, but a quick foreign alloc into foreign integer, okay? And let's go ahead and load this guy up, and let's make sure that we always free the memory, okay, for later on, okay, when you are ready to free it. Okay. And let's go ahead and do that, and you can see if we go here that this is the same as doing a malloc and a free, not using it, and you can see the system pointer being there, but it's actually been freed when you've if you try to access anything out of it. Okay, so let's go ahead and reallocate this guy. Okay, now you might be wondering, just also for completeness sake, CFFI, the with foreign array is available to you. There's a bunch of them up to foreign strings and pointer to vector data. Obviously, depending upon the library that you're using, you can use these functions to give you nice unwind protect guards on what you are trying to do. All right, and that's kind of what we're going to do here today, right now. We're going to go ahead and put this guy into an unwind protect. Now, recall, unwind protect basically is like your try finally block in most modern languages, or if you're using Golang, think of unwind protect as defer. Defer is essentially waits until the scope is completely out of scope, and then it runs whatever the last whatever is defined at the defer keyword, whatever block is defined at the defer after the defer keyword to actually get executed. So that's what unwind protect is. We're going to go ahead and use this guy and our foreign alloc function that we did, foreign allocated test array, to essentially just play around with some of this memory. All right. Go ahead and do this one other thing before we go down that route. That is, let's explore this guy. Okay. So you might be wondering, what the heck is this? You might see things slightly different in other Lisp distributions. I'm using SBCL for today's discussion. But so in Lisp programs, we have obviously stack and heap, just like any other modern programming languages. But when you're allocating something manually, what it's doing is it's using the process memory to actually go and do the allocation for you, and return something what Lisp is calling the system array pointer, which is part of the heap, but it's not part of the same heap as the Lisp heap that is getting garbage collected, okay? There is no metadata inside of this that tells you the type information of the object and so forth. You only know this based on how it was allocated in the first place, and maybe even what we're going to see here, like foreign alloc size, if I remember correctly, is what we need to do. Foreign type size, that's what we need. And then if we specify, okay, so we need to specify, I think CFFI uses foreign type size, not on the object, but we could try. I don't think it's going to be on the object, it's going to be on the actual type itself. Right, so we need to do int, or if we do double, or if we do float, you can see that these are all available for you for foreign type size. There's also alignment, which is used for especially things like if you're trying to make sure that you are aligning your bits when you're packing them to hit word boundaries. You can actually check that out by using foreign type alignment. This is particularly important when you start writing more high performance code, just because you could try and pack as much as you can into a particular word, and then in certain instruction set architectures you can actually make sure that especially if the library code is been compiled this way, you can leverage and prefer using the SIMD instructions that are available at your disposal for that particular instruction set architecture versus actually writing out loop code. So these are kinds of things that you get, but you need to have certain alignments, otherwise there's things related to like how it's going to be in memory and it gets processed, and potentials for cache misses and things like this. These are some important things that you need to be aware of. So I went through that. So what was I going to do with this? Oh, how do we actually go in and set stuff into here? I believe we can actually go ahead. So what if we wanted to actually set something into this foreign allocated object? Okay, this test array. Well, obviously the way you do it is you have to first dereference it. You have an integer pointer there, so you have to hold on. Can I do this way? Well, let's see. I know on the C side you'll be able to access it and return it, but obviously we need to see if we can actually do this. Let me see if I can do print. This is probably going to blow away my, give me a memory leak. So let's check. Test array. 5 is not of type. Yeah, that's what I thought. Let me see here. It was pull up something here. Just give me just 1 second here. I'm just looking at one thing here. My Lisp is different. Oh, here we go. So the way you would access this guy, I messed up this guy, is by doing the following. So we do CFFI, CFFI memref, okay, and then you need to specify here in memref the pointer that we're using is SRA. Then we do the type, which is int. Okay. And now we can go ahead and set this guy the way we expect it to, and this is how we'd end up using it. So remember, everything that you end up leveraging inside it's not a system array pointer. Did I mess that up? Hold on. 1 second. I messed this up. Hold on. On the, let me restart my Lisp. Sorry, I'm going to restart my Lisp here. Here we go. And let's do the REPL. Let's do this example. Oh wait, we have to load here. We'll go ahead and do that parameter here. You know that this is a system array pointer. We're going to do CFFI memref. See if we can return it. You can see that it's not initialized. So let's go ahead and do this. And then do that. Interesting. I'm wondering why that didn't work earlier. And if I do memref here, and I do test array, and we can see that it's actually been properly cleaned. Oh, dummy. It's because of the fact that I have it in an unwind protect, but I forgot to reallocate every time. That's the reason why. In that example earlier. Okay. So let me just go ahead and do a quick free here. And let me correct my code, and we can move on. Okay. And I'm sure if I now actually go ahead and try to memref this guy, I get an error. Yeah, it gets him clear. Okay, it's been freed. Alright, let us do this. Let's go ahead and do, right, take this guy out. We're going to clean this up a little bit. So we've talked about foreign alloc, just as a quick review. Create a variable, allocate variable on heap using unmanaged memory. And this is important to know, just because this way when you see code like this, you will know that they wrote this for some external library language, not for themselves, unless they're doing high performance data structures, in which case we can actually use this to actually create high performance data structures hidden by a Lisp interface. And in fact, there are languages that adopt this. Sorry, not languages. Some products have actually adopted this kind of technique. I encourage you, if you ever get a chance, to find some of the techniques that was used by the Franz. They actually had a talk at one of the Lisp meetups on writing out high-performance data structures in Common Lisp by escaping the Lisp heap and using their versions of essentially system array pointers inside Allegro Common Lisp to write some infrastructure for some of their database projects. It is available on YouTube. I'll post it in the YouTube description for folks who are interested for some of that stuff too. So let me just go ahead and quickly fix this guy. Okay, put this in here. Let's do that. Let's make our test array this. Oops. Foreign alloc. Int. Okay, so we now have that. Take this guy out. And let's not call it test array, let's say test value. Nice test array, test value. Okay. Okay, so this should do what I expected to, but we will see. Yeah, there you go. So now, this is kind of the pattern that you would normally use if you're using foreign alloc and foreign free directly, right? It's not something that you would end up wanting to use directly, because over time when you're writing out code for your own languages or external stuff, you would probably do something a little bit more advanced. There's abilities to, like, for example, leverage writing out to, writing proper Lisp objects and then being able to map between Lisp and C. Again, this is going to be, for today's discussion, I'm kind of going to focus on just the quick overview stuff, just to get you guys up to speed when we start doing some other experiments. But again, the more detailed stuff is available on, I defer to both the CFFI user manual and Bagger's excellent 2-hour tutorial for, obviously more information. The two other things that I want to obviously show you is mainly when we were talking about test array and it being null through the access of its through the access of its memory by using memref. There is actually a couple of predicates available to you by CFFI to actually check if something is null. And in this case, we had null p here, and we could just provide the pointer, and it'll just tell us whether it's null or not. Okay. Although I'm surprised that it's 0, but it says that it's not null. Oh. Let's see if this is. Okay. Oh, because this is pointing to memory that's been freed, but it's allocated. It's not. It technically is not null. It's actually pointing to a different than actual memory location. That's right. So let's go ahead and we could. How can I show this null pointer thing to you? We're going to come up with an example for pointers when we start talking about C libraries. I can break it up. The next thing that I thought I would just quickly go through is writing your own library in, say, C, and then reaching out and being able to leverage it. Now, I've already kind of did this before for those of you who joined me during the beginning of this discussion. I have a basic library that I just created in my math with an add function here using standard C++ style semantics. One thing obviously that I should mention, this technically will not work now that I think about it because of the fact that I compiled this with G++ instead of C, and I didn't make sure that I maintained C name mangling. So let me just go ahead and correct that. I have to first fix the CMake list to say that this is a C project, not a CXX project. Make this guy my math C. Go into my shell, move C++ to math.c. Go into the build directory. Probably do just a quick CMake. What? What do you mean you can't find CMake? I just ran. Hold on a second. Okay, so for some reason it is not. Let's just quickly do this. I'm wondering if it just didn't load my bash profile into this. Okay. 1 second. Okay. Just do this. Okay, hold on, I gotta create another. I have to create another shell. I'm gonna delete this shell and create another one. eShell, CMake's not found. Okay, so I'm just gonna go ahead and quickly do this behind the scenes for you all. Because I do have it, it's just that for some reasons Emacs is not finding it, and the eShell isn't finding it in the path. And just go ahead and run this. So now we have a proper C library. To test this, I went ahead and created an example. Again, I'm going to have to probably, for the sake of completeness, do this example.c gcc -l build example.c -o and my math. Oops, right. I have to fix this code. Because I wrote this originally has a C++ program instead of has a C program, which means I have to do this printf I plus 7 equals %d n add 57. Okay. Oops. Where is eShell? That's what I wanted. Okay. Let's see if examples actually finds my That's weird. Okay, hold on a second. I'm going to move this into the build directory. It's probably not liking the fact that I've tried to cannot shred object file, no object directory. Hold on. Example. Okay. Let's see if I could do this here. Example. There's something I'm missing here. Hold on. Did I my shared library miss something here? Hold on a second. Just fixing a bunch of stuff that should not have caused much of an issue, but may as well just double check. Okay. And since we're doing C, I think the pragma ones also will have to be fixed as well. So let me go ahead and do that too as well. My math. No, hold on. My math.h. We're gonna have to use the old guards. My math.h. It should be good. Show. Okay. Let's quickly do this one more time. Okay. And happens here. It should recognize that we have libmath here. Example. Created the executable, but it has trouble still loading the shared library. Why? It's probably not liking. Let me make it a static library because I think you could do the same thing if I remember correctly. 1 second. Oh, wait. No, it's going to have to be the, alright, hold on, let's see what's going on here. So I'm probably going to have to do that. Okay, I see now. I see what the problem is. I have to do LD library path equals $LD library path colon build. Let's see if this works. There we go. Okay. So this is here. Alright, so it looks like our library's been appropriately built. Everything is kind of correct. But now what are we going to do? Let's say we want to leverage this guy. Okay? So the exercise is loading the C library into this Lisp image. Okay? So the way we do that is in CFFI. And again, I know I am not giving you guys stuff with objects and stuff like this. This is, again, not a complete tutorial on this. I can certainly add this, but I want to do that as part of a much larger project. But this is going to give you kind of a taste of how this kind of all works. So this way, if you don't understand how this all works, then certainly you will not understand a lot of the other lifetime stuff that we get started on it. So the first thing we need to do is actually load the library, okay? Load the actual foreign function library, okay? So the way you could do that is by using CFFI load foreign library, okay? And this specifies the actual library path, okay? So now, first, let's just double check to see what our current directory is. I believe this is actually going to be Lisp projects. So I'm going to go ahead and provide libmymath, and then the search path will include one main thing, which is software projects, Lisp projects, my math build. Okay, and let's see what happens. Cannot open my. Oh, right. I have to give the fact that it's an SO. There we go. So we now have it loaded up. Okay. Now, once this is loaded, all the symbols are available to us, okay? So now what we could do is we could, actually it might be better because we created, no, I did absolute value, so this should be okay. We can now actually call out to this guy by just creating what we did before. And let's go ahead and back to this slide scratch. Okay. And let's go ahead and get this guy up here. Okay. And we're going to now define def cfun and add my math add. Okay. And we do int, and then we do a int b int. Okay. And again, you can see the definition is going to create. Wait a second, this is wrong. This is creating an int with a single argument. 1 second. Why is this? Let me see what happens when I do this. My math add. This should have been a 2-argument function. 1 second. Did I mess something up? Treat everybody the same, blah, blah, blah. There is some difference here with multiple arguments that I must be missing. Let me see something. C function return type args. Oh, maybe I have to do this. I see. I have to do this, and then be. There we go. Right? There we go. Yeah. Because it's creating a closure within a closure. Each of them recurring the arguments. Combined. So now, if I go and say this, you can see that it calls out to the thing. Now, one thing that most of you are probably asking yourselves, how the heck did Common Lisp know when I loaded the so object that the add function that I created is the add function. So the add function that I created in my math is the add function that it should be referencing. And that is actually because of the fact that in C, there is a global namespace, global symbols, all right? There's no concept of namespaces actually in C. So this is actually why in a lot of source code you may have encountered a bunch of folks add a bunch of prefixes to their function names. This is precisely why. It's because the prefix is kind of a mnemonic that allows them to realize that this is part of this library, right? Obviously, this shouldn't be new to the folks who are in coming from C and C++, and even other languages that might have single namespaces. But it does require you to recognize this. One final thing I want to kind of end this discussion on, and that is I'm going to require myself to actually go and restart my REPL to show this, is that these def C funds and things that you're creating, they're actually conveniences around a big thing that that comes into essentially how CFFI works, and that is CFFI foreign fun call. All right. So to show this is I'm going to go ahead and reload my library that I created, and what I'm going to do is instead of using def cfun to create a convenience function for you, I'm going to show you what this actually would look like, so you can see why def cfun is actually a better approach to actually go and reach out to this. So let me go ahead and do that. Give me just 1 second here. I just got to make sure that I get okay, so if I remember correctly, I have to do right, so what I have to do is I have to do okay, CFFI foreign fun call add, and then for each argument I have to first specify the type that I need to provide and then the argument. So if I do int 5 int 7, this should work, right? No values. Hold on, what did I do wrong here? Hold on, it should have foreign fun call. I do int 5 and 7, or wondering so what exactly does it return? Did I forget that it doesn't return something? Okay, so just use this. I thought I did this right. Okay. Let's see something. Let's see if I could just see. Okay, that's what I thought it would do. Okay, let me see something here. There we go. I forgot to provide a return type. Okay. So here in this call for foreign function, and this kind of matches what we convert here. First two are the arguments. Second one is the actual return type. I forgot that you have to explicitly specify the return type. If the return type is not specified, it actually eats the variable, thinking that the return type is not needed and treats it as a void function. So this is something that I have to periodically remind myself. So that's kind of all I had today, just for this brief overview. Obviously, again, there's a lot more to the C foreign function interface, especially when you're trying to deal with mapping between Lisp objects and C objects and so forth. But the main reason why I want to at least set the stage here is because given this ability to actually access C symbols and such, I realized that it is possible now that you could potentially take, say, a Rust library, and if you convert it into an SO, you should be able to do the kind of the same stuff that a lot of folks are doing inside the Python and even C++ communities of calling between Rust and these other languages. And in fact, if you actually read up on the CFFI manual, one of the things that it specifically calls out is the fact that its primary role is to mediate widely varying foreign function interfaces in the various Lisp implementations with CFFI. And it also calls out the fact that the concept that that they created with CFFI is fairly complete, and it could be generalized to calling other languages from Lisp and not specific to just C. It's just that its C support is most complete. I think this is something that we need to, at the very least, take into account, and actually, in some situations, maybe even extend it to allow the CFFI, as it stands today, to allow us to essentially be the foreign function interface to any external language, because the concepts that they've defined, the notion of foreign function and the notion of foreign data, is universal regardless of which language you're trying to write bindings for. So I think this is something we should think about as a Lisp community. This is something I'm going to try and do some more experiments on, and hopefully through our series of talks about this we could see if we could do it. I will say that the short-term thing of interacting with external libraries with Lisp, as long as their symbols are C, makes it easier, because then you don't have to worry about supporting their name mangling scheme inside of your Lisp implementation, and you don't have to think about, especially from a Lisp application developer's point of view, the semantics necessarily required to actually move stuff in and out of in and out of Lisp, because you're using C as being the common denominator in terms of the memory management, between the Lisp process and the external foreign program. So C no longer now becomes the place where you write the code necessarily, but its representation becomes the place, the protocol upon which Lisp will be communicating with other foreign languages. So I'm going to leave that food for thought for all of you here. That's all I have today. I'm going to pause for just a minute or two just to see if there are any questions, and if not, I'll hold it. Any questions from the folks on the Jitsi channel? Okay. Well, next week I'm hoping that I will have a running version of SBCL as a shared library, and if I can get that up and running a little bit cleanly, I will then move on to, I would say, the next part of our series of experimenting with CFFI, and that is, how do we call Lisp from C once we define something in Lisp? And once we've battled that direction, we can actually go and start talking about, well, how do we call Lisp from other foreign languages, not just C. Thank you for your time.